Okay, so morning. Hope you have great Thanksgiving holiday. But a couple of weeks later, we will have the final exam, so be ready for the final exam. So in the final exam, the time and date is the 10:45 a.m. to it's 2-hour exam in this room on the December 11. I think that is a Monday. Okay, so if you have I think the one student requests extended the exam due to the physical problem. So if you have any issue, according to the school policy, only the medical, the issue in case of the medical issue. So with the proof of the medical status, so it can be extended or the makeup. So otherwise, there is no exception for the exam. So please be ready for the exam before we start. So that is the December 11th, couple of days after the exam. I think I will allocate the office hour to check your final exam sheet. So this time it will be the paper-based, so unlike the midterm exam, so you are able to check your final exam sheet only. Okay, do not ask the grading of your project. Do not ask the missing attendance or the quiz. You need to check the correct the problem before exam start. That will be probably the last week of the semester. So before exam start, so you need to clear every issues, any problem with the GA or the only the exam sheet you can check during the final after the final exam. Okay, so final exam will cover the chapter 7 through the 13. So it will not be the comprehensive. So you can just start after the midterm exam. Okay, then during the winter break, I'm going to lead for the winter session in our sister university. So I'm going to leave for China the December 15th. So I will not be available. So if you have any issue on the exam and anything great, so you need to check before that. Okay, I will not be available after that time. Okay. So any question regarding to the final exam? I'm going to give a little bit more information about the format of your final exam. That's probably the similar pattern as the midterm, but this time there's a paper-based. You may have a chance to get the partial point, so unlike the midterm exam. But do not expect the easier one. The average score of the paper-based and the computer-based is pretty much similar, based on my experience. Okay, so if you have any conflict schedule with this one, you need to ask the other professor in the class, because this is assigned the schedule by the registrar office. Another class should follow that assigned class. Yes.
Yes, Professor. Regarding the project 2,
yes.
we'll find out our grades before the final exam.
Oh yeah, sure. So GA also leave. Once the exam starts, the final exam week, so he and me will complete everything. So I think that he will allocate. We discussed about the finalize for the demonstration of that will be better, because each student has the different the developing environment. Sometimes the GA cannot reproduce the submission. So he will allocate the demonstration hours before exam start. Any other questions?
I have a couple of questions regarding the project.
Yes.
So when we are trying to keep a file which is like more than the existing PFS directory file, right? So PFS directory file is 10 KB, and when we are trying to put some 15 KB or 16 KB file, how should it handle? Like
your question is if we need more space. So
no, like when we open some directory, PFS directory file.
Directory, we are not going to implement the directory.
We open PFS file.
Yeah, PFS.
Right.
Yeah. So file system.
Right.
Yeah.
If it is not available in our directory, it creates a new file of size 10 KB.
Not available means there is no existing file system.
Right.
Okay.
Right.
Yeah, you need to create the PFS file.
So that creates a 10 KB file. Right?
Yes.
And let us say we are using a command called put, which puts another file
Yes.
into our file. So if that file is of size 16 KB,
Yeah, sure.
so that is less than.
Yeah, you need to extend the PFS file by adding another the PFS file.
Oh, we should handle that file.
Oh yeah, sure. That is mentioned in the project description. So that I suggest to create the .pfs file. Then it should be extended 1, 2, 3, 4, something like that. Okay, but you don't have to increase the shrinking. Okay, you don't have to shrink the unused file in case the delete or remove the file. Okay, that will be more complicated.
Right.
But you are able to extend.
Okay.
Okay, at that time you need to update the header information because the number of available block will be increased and the number of, but you should have you probably should have the limitation, okay? Like so if you upload the 10 megabyte file, so you may have the assume, you can have your own assumption, the file limitation, like the less than the 100K, something like that, okay?
Professor, regarding the put R,
Yeah.
my file and then the remarks,
Uh-huh.
are we, so we're opening the file uploaded to PFS
Yeah.
and we're adding a comment
To the file control block.
to the file control block and
Yes.
not the data.
Yes. You don't touch anything for the file itself. Okay, so we are pretending how to implement the PFS, the file system. We are not going to touch anything for the file itself or not the NTFS, your host file system. Instead, you are going to manipulate your own the file control block FPS.
So in the case, the file control block has to have the remark section.
Oh, sure. That's actually the key part of your implementation. When you design the file control block, the data structure, you need to add one more. That is not in the original file and the file system. Okay.
Right.
Yeah.
It's not displaying when you click
Yeah.
on
So
that.
that's the additional thing you need to think about because some students just use the SADs. So to understand the file system itself, you need to modify the FPS, the data structure by adding the remarks.
One more thing, Professor. Like there is one command, like when we click on this run, right?
Run.
Run PFS.
Oh yes, so starting the file system.
No. That's at the end of the document. You can slide.
You mean the executing the file,
Yeah.
execute the file on your, yes.
No.
So for example, if you have the notepad, you upload the notepad, you should be able to run that file if that is the executable file, okay? At the time you need to have the link to the, the program that can execute. I think that is for example, TXT file.
Right.
So you can run the notepad. So
Right.
you need to have the link. Which one is linked? That can be also managed in the FPS.
So the thing is, like if it is in the GCP, right? We cannot open up that notepad and show
No.
it on-
So you need
So
to
we
find
need
that the proper, the executor, what is that, the VI or any editor. Yeah.
So can we show the output over there in the normal VA?
Yeah. So you can use the available program that can run, or otherwise you can limit also. Like you are able to run only the TXT file only. So not the Paint or the other
Yeah, so to
applications that are running on other operating systems. Okay, so please be ready for the rest of the semester. So this is anyway the core course of the computer science. Most of them, you guys are major in the MSCS, so please do your best. And for the undergraduate student, I strongly suggest to do something, the contribution on the second project, that will be extra point, and also for the file. Oh, by the way, on Canvas, don't pay attention to the percentile. Okay, that's not the score. So Canvas automatically generate the percentile. For example, if you got the quiz, the 100 out of 100, they consider weight 100. Okay, so that should be the changes. So, but there is no way to remove such a column. Okay, so do not pay attention to any percentile. Only pay attention to the grade. Also, I need to sum of the grade is out of 10 out of 100. I definitely adjust the weight of each activity. Then I will calculate the the grade, that is the weighted, based on the weighted total. Weighted total will be 100, like the 30% midterm, 20% midterm, or something like that. Then instead of applying the curve, I usually adjust the range of the grade. Like the A is not like the 95 above, I roll down to make the proper distribution of your final grade. Okay, so I will let you know once we got the final exam the result. Otherwise, it will be the disaster most of you. Okay, and undergraduate will be separate pool to decide the final, because some this is actually the design for the graduate level. So, but the undergraduate student are a little bit tough. So I separate consider the final grade. Okay, so if there's no more question, we will continue the chapter 8. I will little bit the speed up to finish the chapter 8 and 9 on time. So surprisingly, next week is the last week. Okay, so but before we start, as we have done many of the time, so let's go back to the basic architecture of our computer. So this is our computer. So it has the CPU. So that is the main part of the component of the computer system. And also we have the memory. Okay. Then we have, as we discussed the last few weeks, it has the I/O system, including the hard disk drive and the file system and the more. They are connected to the bus. So we have the extended bus, and then they can transfer the data. Okay. We are not going to discuss the details of each component, the hardware part, but without understanding the hardware, the computer architecture, it doesn't make sense to understand the operating system. Anyway, operating system is a software on top of such a computer architecture. So it is a good idea to take a record what you learn in your computer architecture class, or even the microprocessor class or compiler class that you have taken before. So that is I think the fundamental to understand the operating system, and especially for the memory management. So very briefly, we will go over the such a computer architecture part. So CPU, what is the CPU? CPU? It's a central processing unit, right? The process what?
Instruction.
So instruction, eventually instruction. It can process something, the information, but that information should be coded by the instruction. So each vendor, like AMD, Intel, or the IBM, those who are manufacturing the CPU, they actually design the how many and what kind of instruction the process in this. Okay, so even though you are using the same operating system, but with a different CPU, you need to have the different version of the operating system, because depending on the CPU, the number of instruction and the types of instruction are different. The operating system should be compiled differently. But anyway, so the CPU has what inside? So which one is the most popular component of the CPU? It should process something, right? So process what? To process, they need to have the information. That information is where? So CPU has the register. So register is the basic component of the CPU, okay? So there are different types of the CPU. This is the storage. It's the really top of the pyramid of the storage architecture. It's the fast, but it's not the huge. Okay, it's usually small. So this register, what types of the register do you remember from the computer architecture class, and specifically the microprocessor class? What types of the register? program counter. So what is a program counter?
Basically, select shows the index of the instruction to be
Where is actually the instruction?
memory.
Instruction is all the way down in your file system.exe file. Okay? This is the set of instruction. Who made this one? Your compiler. Okay? Whenever you double click or the type of command like the pfs command, you compile that to have the executor file that has basically number of instruction. That actually the originally defined by the CPU vendor. Okay? So this one you need to program counter has something index, we will see detail, but to actually access this instruction, no. There's huge gap. It's a speed gap. It's a slow and so fast. So cannot access the lower speed device directly. Instead, we are going to use the memory with what kind of data structure? Process. So we talk about a lot the process. So if you double click or if you run the command, then this instruction will be loaded into the memory somewhere in your the memory structure. Okay, then what is this one? Memory. Memory is if you define the memory in one sentence, it's a
Set of index
set of index. In other words,
address.
it's nothing but address. Physically, it consists of the grid side, and it has something the electric, the circuit, and if you have something signal, so this is represented by the 1 or 0, turn it on, turn it off, and so on. So then finally you can represent something data. We will see a little bit more detail about this. But we can access it. So we can represent the binary information on the memory. Okay. Then it can be represented by the address. So memory is nothing but the set of address. Okay. Sometimes you can represent the memory if you remember the microprocessor class or any computer architecture class. Sometimes we can represent the memory on this way. This is a 0, 0, 0 and 1A or something like this one. Okay, so because it can be represented by the set of sequence of address. If we know that address, we can bring for example, there is which one is the most popular instruction? Move. Okay, so we have, let's say, the move and this. This will be somewhere in your memory, and this one has the address of the A. So this, the CPU should know where is the next instruction index or it's the address, memory address. The program counter keeps such the address of the next instruction, for example, A. So if you read this one, this will be, how can you communicate between the CPU? CPU would like to know, would like to get the next instruction, then it has the address. There is a bus between the CPU. Mostly there are two types of bus, address bus, data bus. So sometimes if you are taking the electrical engineering class, it has like this, the circuit, like this one, and each pin is used for specific purpose. So this one will be used for the address. How can you send such an address? And how can you send data between the CPU and the memory? The bus is nothing but this one. If you plug in this chip, like the CPU or the memory on the motherboard, okay, they are connected like the wire. So each wire can send the electric signal either or 0 or 1. Okay, by sending such a data, you can represent the move. We see the move is not the language used by this hardware. They will use only binary 0 or 1. Okay, so binary code is coded. So we will see the little bit more the details format of this. but this chip can send. But there are two types. This one is used for address, and this one is used for the data. So by sending the address, this one, to the memory, then the data will be sent back to the CPU. Then there is the information of the register. So the current, the instruction will be stored at the register also. Okay. So then also there are other specific types of the register, like the status of the CPU, and also some more depending on the CPU, some more the instruction, specific purpose of the instruction are used, and also plus there are what? ALU. ALU is what?
Arithmetic logical unit.
It's a logical unit for what? Basic operation, like the mathematical operation, plus, minus, and shift, and so on. So using such as in the circuit class, so you probably learned such a plus, minus, and the logical unit of that you draw such a circuit. So if you are majoring in the electrical engineering or the computer engineering, you probably know. So ALU has such the logical unit, so it can process something basic operation. And plus last one, it's not the specific component of the CPU is general. So last part is usually that you know, CX, AX, and so on, general purpose. So general purpose, you can keep if you bring the data of this one, it will be stored at here. Sometimes the memory address can be stored at here and the general purpose. But each one, AX, BX, CX, has something, the details of the purpose. But you should learn in the microprocessor class, right? No? So learn. So microprocessors, such a hardware are the basic to understand the computer science also. But many of the students, even more importance of the engineering part in the computer science, please pay attention and study more such a hardware part. And also, okay, so this is the CPU. Then what we are interested in this chapter is this part. So if we have something like this. So this is an example of what? It's a move. So if you take a look at the back, after the index or the appendix of your microprocessor, the class textbook, you can see the bunch of lists of the instruction, and each instruction has the operation code, like the 100011. What is that? For example, that is move. So each instruction, like the Intel defined the 150 instruction, each one, number 1 through the number 150, like the move is the 100011. Okay? So this is the code. This is actually the move, the instruction. Okay? So each instruction has their own code. Actually, this is for the semantic meaning. So this is where it's used for assembly language. Okay? But this one is the operation code. The operation code is actually stored at the program, memory, and eventually processed in the CPU. So for example, each one has defined each such a binary code is defined by the CPU and processor. Like I'm not sure what kind of processor you use in the microprocessor class. x86, for example, it's a 16-bit processor, which is mostly the old one popular and used for the IBM comparable PC. And then, so for example, so this is used in the x86 processor and move. And then it has it used how many bytes? 16-bit, 2 bytes. So for example, the 100011 is the command, the assembly, the instruction command. Okay. Then this one is the additional, and depending on the operation code, it can be used or not. And MOD is whether this is what's the meaning of the RN. So depending on the instruction. It can be various. And this is a register number, and this one is also the register number. So for example, based on the mode. So 001 is the CS. This is the name of the general purpose, the register, and this is the RM is a BX. The BX is also register. So move the information in this one to the this. Each register, what's the size of the each register?
1 bit.
1 bit. So you can keep only 1 bit of the data. You cannot keep the instruction, even the instruction code, depending on the CPU. Your type, 16-bit is a 16-bit. And the 32-bit computer is a 32-bit. And 64-bit processor, 64-bit. Because of that, if you see the microprocessor texture from the old one to the current one, it can be changed. Like you will see nowadays E extended, because the mode nowadays is 32-bit and the 64-bit. So it will be extended. So each register has the 32-bit or the 64-bit. So let's say there is a 16 the bit, the processor. So in this case, because we do not have any E extended one, the register. So this will be stored at the where? The register. Like the IR, the current, the register. Current, the instruction register, current instruction will be stored. Okay, then before that, this one, for example, this one will be stored what supposed to be the memory. Okay. Then how does it store? How do you store the binary information in the memory? You probably learn. Did you read Gulliver's Travels? Gulliver's Travels? No? You did, probably. Either English or your own, the other language. So, do you remember that if you read the not very short version for the kids, but if you read by the way, who is the author of the Gulliver's Travels? Jonathan Swift. That's the common sense, even though you are in the computer science. It's the Jonathan Swift. So original, the text, if you read that, there are arguments between the egg. How do you broke the egg? Do you remember that? There are two types of people to break the egg. You have an egg, right? When you make the sunny side fried, or the whatever. So when you break the egg, there are two types. One person, so actually egg is not oval, right? It's like this shape, okay? Sharp, and this is a big, and this is a right.
Blunt.
So which one? So they argue and they fight. Which one is better? So those who support the break this part is called little endian, and this one big endian. Big end. You can break the egg from the big, and you can break the egg, the little part. So which one is better? The idea of such an argument is it depends, as we have seen. So it's not we cannot see the clear answer for this. Same thing when we store the data in the memory. Actually, it's not in only the memory, but because we are using the binary number, binary code to the electrical system. So there are two types of storing the data in the electrical device. So one is big endian, another one is little endian. Do you remember that? What's the difference? I think that is one of the most popular question in the microprocessor class or the basic computer science and computer engineering class, right? Anyone who never heard about the big endian and the little endian? Everybody heard about. So what is the big endian?
Base.
We heard
base of the.
You heard, but you forgot. That's natural. After the exam, right? So for example, we have the first part of the binary code 1 0 0 0 1 1 0 0. Okay. And another part is 1 1 0 0 1 0 1 1. It's a 64-bit process. Okay. Then this one is called what? We have bit, bit, bit. This one is most significant bit, MSB. And this one? Least bit. What's the difference? This one and this one are the same?
No.
If you change one bit, this one is huge different because the value of, let's think about only this 8 bit, okay, because it's 2 bit. So this is what's the value of this position? 2 to the power of 7, okay? So 128, okay? What about this one? It's just 1, okay? So they, even though they are using the same 1 bit, okay, in terms of binary, it's turned it on, but their value itself are the huge difference. So this is the most significant. Significant means big difference. This one least significant. So big endian store the what? Most significant part first. So for example, so when you store the binary number, when you represent the binary number in electrical the device, how do you use? We are using hexadecimal, 16. What is a hexadecimal? 0, 1, 2, 3, 4, 5, 9, A, B, C, D, and so on. Because it's the power of 2 to the power of something. So do not lose any the data if we are using the hexadecimal. So for example, this one, 1, 0, 0, 0 is in terms of hexadecimal, what is the value? What's the value of this one? 2 to the power of 3 is 8. Okay? What about this? So 1, 1, 0, 0. It's 12. 12 means A, B, C, 10, 11, 12. It's a C. It's a total A, C. Okay? And what about this? It's also C. Okay? And this one is A, 2, 1. It's 11. 11 is the B. So when you store this data in the memory, the big endian use most significant part first. That is because you need to, in case this is the 8, we separate by the 8 the bit. So each one has this one AC, and C is a B, or CB. Like this. You can store the data, and from this one you can read the data. This is the big endian, the approach to store the data and the read. And what about the little endian?